This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make lightning protection easy. If your wind turbines are due for maintenance or repairs, install our Strike Tape Retrofit LPS upgrade at the same time. A Strike Tape installation is the quick, easy solution that provides a dramatic, long-lasting boost to the factory lightning protection system. Forward-thinking wind site owners install Strike Tape today to increase uptime tomorrow. Learn more in the show notes of today's podcast.
Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back to the Uptime Wind Energy Podcast. I'm your co-host, Dan Blewett. On today's show, we've got a great guest. Matthew Stead, CEO of Ping Services, is here to talk about their Ping monitor system. Alan, really interesting conversation with Matthew today. What were some of your takeaways from it?
Well, Ping monitor has a great audio recording system, basically data analyzer system that just magnetically sticks to the side of the wind turbine and takes really important data, so you know if your wind turbine blades are having problems. It's the thing about this, and talking to Matthew, is so fascinating. It seems like it's such an obvious solution, but no one's done it until we got to Ping, and it's a fascinating device and a really interesting company. And if you own or operate wind turbines or repair wind turbines, this is a good one, because not only do we get to see the technology, Matthew actually shows you all the innards of this Ping monitor, but also describes how the system works, and that's what you need to know.
Yeah, it is a really cool system, because you think of, like drone technology is becoming ubiquitous, right? Like camera technology in general. All those things seem to be like the go-to for assessing damage, and of course they still are. But so the Ping monitor system, if you're unfamiliar, it's a little dome looks like about the size of a fire alarm in your home, and a large part of that dome is just the windscreen, so it's preventing excess noise, just like you see on our microphones here, the foam pop filter. And so it listens to the wind turbine blades as they come through their cycle. So every time it goes whoosh whoosh, it's listening to that sound, creates a baseline, and then over time it's comparing that baseline to the new normal. So if your wind turbine gets struck by lightning, if it has leading edge erosion a couple years later, it's going to sound different. And as you'll hear right from the get-go in the podcast, they got the idea from that wind turbine technicians could hear the difference themselves. So like, hey, we can tell like something's up with this blade, like it sounds weird. And again, that's just something that you hear in like the auto industry. You hear it everywhere. Like everyone knows, like, yeah, my dishwasher is making a weird sound. Something's broken, right? But you really take that for granted, and it's such. We really do as humans use like all five senses in just navigating our world and figuring out what's going on. And when things, even like your own stomach, your stomach's gurgling, you're like, oh no, I ate something. So it's it's like one of those, why didn't that get thought of sooner solutions that makes a lot of sense for continuous monitoring, just to get ahead of something and say, hey, maybe we should deploy a drone company to check out this blade because it sounds different and it sounds consistent with, leading edge erosion or a lightning strike, puncture damage to this blade.
So not only can they detect that there's a problem, they can actually predict what that problem is, like leading edge erosion or lightning
that's what's so
strike
interesting
damage.
about it.
Yeah, it's a really powerful device. It's so small and so powerful, and it's going to change the way we monitor wind turbines. It totally will. So that's what makes this interview so fascinating.
It's just really like one of those interesting, like I said, why didn't we think of this sooner kind of things that's going to clearly make an impact on the wind industry, especially as you get offshore, where, like we've talked about in other podcasts, you don't want to be sending people out there to maybe find something. Like, you want to know for as certainly as you can before you send people off to these inhospitable environments, way offshore.
The Uptime podcast is here to to introduce those new technology breakthroughs and those new ways of looking at old problems to get them solved. That's what this whole podcast is about. And I really like when you can bring new tech and describe it, show it like on our YouTube channel, so you can actually see the technology, because that you really not a lot of times get to do that. And I think for the engineers and us techies of the world, it's a really cool thing to see.
Yeah, so without further ado, we're going to jump to our conversation with CEO Matthew Stead of Ping Services. All right, so we're going to jump right into it. Matthew, thank you so much for joining us. I mean, I guess I could say across the pond, but I think you're our longest. I mean, what is this, just across the world? I mean, hello from Australia.
I'm in the future, actually. It's tomorrow.
You're right. This is our first interdimensional podcast. Pretty amazing. Well, a funny story. A teammate of mine a long time ago, because I have a sports background, a teammate of mine had a quick puddle jump, or not a puddle jump, but a very quick flight. And he was going right across the time zone, like a 45-minute flight, and he was going to land earlier than he arrived, or he was going to land earlier than he left. He's like, I ain't getting on no time machine. One of my favorite just random quotes from all time. But yeah, we really appreciate you being here. Very cool that we got to connect with you from just, from Australia, from so far away. And you guys obviously have a great product that's starting to really take off. So let's dive right in. So the Ping monitor system, your background is in sound and acoustics. So tell us, kind of how you got started and where this idea came from.
Yeah, so I'm an acoustician, so I specialize in sound, and through that work, I've done a lot of work with wind farms. So environmental, noise compliance, testing, siting, all these sorts of things. So a lot of work with wind farm operators. And through that process, we got to know a few operators, and one operator in particular basically challenged us. So the challenge was technicians on site, as they travel around, can hear blade damage. They might stop, get out of their truck, have maybe take a phone call, and then have a bit of a listen. And when they have a bit of a listen, if there's blade damage, quite often they can hear it. Mm-hmm. So the challenge he made to us was that, if technicians can do it, why can't you make a machine that can also do the same thing? So that was the point of what we're doing. And so we're listening for wind turbine blade damage.
Yeah, that's such an interesting idea, and it's such a common one, right? Like, you take your car to the shop, auto mechanic lets it run, and he knows with the knocking sound, the little pinging sound, the really subtle sounds. Like, I was listening to a bike go down the street, an electric bike here in Washington, D.C. the other day, and it was screeching. I'm like, this poor guy, making a delivery on it, but it's like, something's very wrong with your bike there, sir. It sounds like it's going to explode at any moment.
Yeah.
I know those are obviously extreme examples, but I mean, obviously these wind turbine blades are going so fast and they're so big, so there's a pretty significant sound. And your monitor is tell us a little bit about how it works. I mean, where is it attached on the turbine? And what is it kind of doing to separate like the noise from essentially like the signal?
Yeah, and that's one of the hardest things, is that there is a lot of sound around wind turbines. So it's not just the turbine making sound. It's birds, wind in the grass, sometimes cattle, whatever, aircraft. So I'll show you a bit of a prop in a minute. But what we do is we basically synchronize our listening with the sound of each blade as it comes past. So what we do is we work out how fast they're coming past, and then we only listen for things that are occurring with that frequency. And that way we can exclude the things that are short-term, that only occur periodically, and only listen for the nice, regular blade pass-by sound. So that's the basic principle. There's also, different damage has different characteristics. So, erosion sounds a bit different from a crack or a hole. So we've got different algorithms to, listen for these different types of damage. And, this is the device. This is our listening device. And then that goes in our windshield, and that's attached to the base of the turbine with magnets. So it's sort of at ground level. You can be a bit higher if there is risk of theft. So that way, by being down near ground level, we can hear each blade as it comes past.
Each wind turbine is different, right? So the height's different. The difference between the hub and the ground is different. Is there like a butter zone where you want to make sure your device is X amount of meters from the blade tip itself? Like, how close do you need to get the thing?
Well, we've found that for all models that we've tested so far, as long as we're sort of between that 1.5 meters and 4 meters above ground, we're getting good results. So with those arrangements, it's working great for us.
So Matthew, the actual device is about the size of a small iPad or a large iPhone. It's incredibly small for as much technology is packed into the things. What is all inside of that unit? So
this is the actual sensor itself. So we've basically got a microcontroller. We've got a bit of memory with an SD card, and we've got like a connector device and some microphones. So this is the brains, and this is the thing that's doing the listening. So it's doing the processing on here and then sending us the results separately. There's a cover that goes over top of that electronic piece, which is what you see. Yeah. So this is the windshield. So effectively, it's windy around wind farms, and so this is all the pure task of this is to keep out wind noise from our microphone. So the actual, a lot of this is just empty space in here. Yeah, just like with our mics to, keep those sweet plosives out. Sorry, yes. Listeners. Yes. How is the unit powered? How do you power this unit? It's so small and compact, and you got this nice microphone wind protector. What powers it? What makes it go? So the other part, which is attached to the sensor, this is our power and communication module. So it's perhaps a bit hard to see, but in here we've got a solar panel. So we've got rechargeable batteries, solar panel, and also some cellular technology in here. So this is actually the bit that gets our data off, and then it goes up to the cloud. And in the cloud is where the monitoring occurs, and that's where we can then alert our customers from the cloud itself. So this whole unit requires no wiring, absolutely no drilling of any holes in anything. It basically is like you talked of it. It magnetically sticks onto the turbine, and you just walk away from it. Yeah. So we use the plug and play terminology, which is, I'm sure someone else invented that, but so it's plug and play. So you just basically plug it together and throw it on the wind turbine. I think we've sort of timed it. The fastest it can be installed is less than a minute. As far as the communications go, kind of walk me through like the whole process. So obviously it's really quick to just stick it to the bottom of the turbine, and then it's doing its thing. But then where's the data going? Who's it going to? Is it all AI powered? Is there manpower? Who sifts through the data and listens for the relevant signal? So all the algorithms are built into our device. So the device, basically does the listening for us. So there's no technician needed to be listening, thankfully. And so what our device only does is it does the analysis and then sends a summary. So it's basically a daily summary of the condition of the blades. That appears in our cloud, and then that can be trended. So what's happening is we've got a level of damage reported each day, and then if there are changes, or if there's a bit of a step change, i.e. more damage has occurred, or it goes above a certain threshold, the cloud system that we've built up then sends the customers or the operators an email alert or an alert to show that, hey, something's changed here, and you might want to go have a look at this turbine to see if something's happened. So perhaps a good example might be if there's a lightning strike. So, storm comes through, lightning strike. I think you guys understand a little bit about lightning.
Oh, yeah.
But, some blades get damaged, and what that does is if it's, surface damage, it makes a sound, our device picks it up, and then then we can get an alert out to our customer so that that damage doesn't go on for too long before it's addressed.
So the genius behind this is because the circuit board has the brains in it, you're not transmitting tons and tons of data up to the cloud. You're only really transmitting those little step increments of what's happening, which simplifies the system immensely. But it requires a really powerful processor to do that, right? I mean, you're doing a lot of analysis on the board itself. Is that how it's set up?
Yeah, exactly. So, we measure to a certain frequency around 20, 30, 40,000 samples per second. So you can imagine, that many samples per second is a lot of data. So we have to really process it on our device. We take that audio data, process it on our device, and then only send the summary. So the actual summary is in the bytes or kilobytes rather than megabytes, gigabytes.
Oh, terabytes, sure.
Yeah, or terabytes if you kept it going. So this is really the brains behind the whole process.
So the thought process is from the owner's side is that it's really inexpensive to maintain these things. You're not using a bunch of data to upload constant streams of information. It's sending little packets like there was a change made to this happened to this particular blade on this particular turbine. You may want to check it out. It's not like you see some of these systems where they're constantly streaming data and data and data and data, and someone, like you said, has to sit there and overwhelmingly go through this data. And what's the point of that when you can have a very smart processing system on site to do 99% of the work? That's a brilliant way of approaching this problem, because I think a lot of the technologies just don't do that today. That's amazing.
Yeah, and so our system is operating. We're coming up towards 300 systems now, and there's that whole process is automated, so we don't need to have an oversight as to the actual data processing. We still keep an eye on it for our customers, because we want to make sure that if anything happens, they're seeing those things, but we don't need to be part of the chain of the data analysis and then showing the results.
Well, and what's really interesting about solving this problem of continuous monitoring is that you couldn't optically do that well with these blades going so fast. Like, you couldn't set up a camera system to effectively take a snapshot every time the blade goes by. And obviously you don't want to stop them and send technicians up there either, or even stop them just to, get ground-based or drone footage. I mean, it's really interesting that this probably makes the most sense of any of those solutions, because you can just kind of listen. You don't have to get to the more complex stuff, even though camera technology and drone technology has changed so much and is so much more effective and cheap. It's so much easier to deploy, but it's still not that easy to, because again, these blade tips are going 200 plus miles per hour. I mean, there's just no good way to check them all out as they're going by. So it's a really interesting, sort of, why didn't I think of that kind of solution, that it's probably the simplest of all those continuous monitoring ideas.
We like to use the analogy of a technician. So, like I said before, technicians have ears, they can hear the blade damage. But the visual aspect is still very complementary, but just not every day. So we like to think of ourselves as an early warning system. So we can flag something's changed early on, and then the detailed visual can occur, but in an optimized way. So there's no point inspecting towers that don't actually have anything wrong with them. So it's a good way of sort of getting the most bang for buck out of the visual inspection process.
And can you go over, I mean, there's a bunch of different types of damage. I mean, you can essentially detect most, if not all of them. Is that correct? I mean, root cracks, cord cracks, delamination. I mean, what are some of the other ones that your system will pick up?
Yeah, erosion is obviously a big one, the lightning damage. So really, for us to pick it up, it has to be on the surface, and it has to be disturbing the airflow. So it's the disturbing airflow which makes the sound, and that's what we pick up. I guess one little caveat there. So for root cracks and transverse cracks, they are a bit harder for us to hear, and so we tend to focus on the outer 2/3 of the blade rather than the root zone. We have detected some root cracks or transverse cracks, but really our system is focused on the outer 2/3 of the blade, where the bulk of the damage is.
But yours can also detect like creaking and changes in that kind of stuff too, right?
Yeah. Well, actually, perhaps I should sort of talk about something that we're working on. It's a system that actually listens inside the blade. So, for any creaking, groaning, we can listen inside the blade, and then we can listen for more of the transverse cracks, the root cracks, and creaking and groaning and these sorts of things. So,
wow.
There's some university research, University of Massachusetts. They've done a lot of work to prove out this sort of approach, and we're looking to work with them to take that further.
Yeah, so let's talk about that for a minute. So obviously your systems are getting adopted more and more each day, but how did you go through this validation process? I mean, we talk about this with other, CEOs of companies, and how it can be tough to say, hey, let me on a turbine so we can test our technology, because obviously these are expensive assets, and, it's just kind of a hands-off thing unless, they know you well and they know the technology and it's not going to have any, downside risk. How did you, what are some of your case studies? How did you guys get to where you could validate it?
I think probably from our background, because we were fairly well known in the Australian industry. So, the operators knew who we were because we're working on their wind farms from an environmental noise point of view. So from an introduction point of view, that made it a whole lot easier. Mm-hmm. The second thing was that the operators know that the technicians can hear blade damage, so it was a very easy discussion, and they just got it. Oh yeah, I get it. I see what you're doing, and so that made it quite easy. And then the final thing was that we weren't really messing with their devices. We weren't hooking into any power. We weren't trying to connect to their comm system. So it was completely non-intrusive. So actually, I'm very pleased to say that's actually not been a problem for us. So we've been validating our system. I've lost count of how many countries now, but I think we're probably hitting the nearly 10 countries.
Wow,
where we've validated what we're doing.
And so what is like the breaking in process is probably not the right word, but you have to get a baseline, right? So with each new turbine that you're on, they're going to have different, obviously blade lengths, blade geometry, blade tip speeds. I mean, what does the system do to initially get that baseline, and how long does it take? And so if I was a wind farm operator, how long before this is up and running and sending me those sort of daily, report packets?
Yeah, I mean, the daily report packets come straight away. It's just that after approximately a 2-week period, we've seen enough wind speeds and wind directions that we get a good handle on what we call a scaling effect, or scaling factor. So after a couple of week period, we can apply a scaling factor to see, sort of benchmark that against other wind turbines we've already measured on. So thankfully for us, there's actually not a really large variation from turbine to turbine. But yeah, it's pretty much after a 2-week period we can do that calibration process. The other thing, some operators like to see the numbers lower, and then if it jumps, it's more visible. And some of them like to calibrate it a little bit more to their own rating system. So we've got a bit of flexibility on how we set the levels up.
And then, so you mentioned that it's typically on every single turbine, and that makes sense, right? I know some of these, like we talked with Jeff Grabner of Technostrobe, and they're not going to put a beacon light on every single turbine necessarily in a formation, because it just needs to identify where the wind site is. But these need to be on pretty much every turbine to detect that turbine's unique signature, even if it's not that different, because they're all the same, make and model. Is that right?
Yeah, correct. We're only listening for the turbine that we're on. We don't, or actually we exclude sound from the adjacent turbines. So we're just focusing on the turbine that we're on. There was one site where we were doing a pilot and sort of validating our technology, where there was actually blade liberation on a tower 2 turbines away. So so we went back, looked at all the data, looked at it a bit more detail, and we couldn't hear it. So so we really are only listening to the tower that we're working on.
Yeah, it's interesting. I lived in Cherry Hill, New Jersey, which is a place here in the U.S. that's close to Camden, New Jersey. And Camden is a really interesting program with the police department, where Camden had a really high per capita murder rate for a long time. And one of the solutions, besides a lot of just like good community policing and just like a good just relationships between the police and the residents, one of the things they installed were a lot of cameras and a lot of listening devices into Camden, where they could triangulate the sound from gunshots, and they could send police around a little more. And I'm sure all that stuff is, it's really complicated, obviously, but I find it really curious. I mean, would there be a place in the future where, you sort of have like noise canceling technology where you can ignore this, but you can also listen for different types of things? I mean, I'm sure there's lots of different applications for like acoustics. And what are some other maybe peripheral secondary technologies kind of like that might be, or is there anything on your radar for the future?
Yeah, there's a few areas that we're looking at. We love wind, so don't get me wrong, we love wind. But there are a few other applications, and one obvious one that we're working on, and we've actually already started pilots with some customers, is around mining and conveyor belts. So I think, like you mentioned before, bearings and mechanical parts, if they're starting to fail, they can start to squeal and make sound, and that's what we can pick up on conveyor belts. So there's a whole lot of conveyor belts in the world, and we can save a lot of waste. So conveyor belts is one. We're doing some work with a water utility, so for looking at cracks and leaks in pipes, because water spraying out pipes makes a bit of a sound. There's other applications in rail, so like the wheel wagon bearings and the wheels on the wagons. So there's a number of other applications like that. But we're definitely on wind at the moment.
Well, and I'm sure those translate to wind pretty well, right? I mean, there's up in the nacelle, there's tons of obviously electrical components, there's bearings, there's all sorts of stuff. I mean, is that something that's on your radar as well?
We have been asked that actually a number of times about monitoring the main bearing and the gearboxes and so forth. I guess with condition monitoring, the approach of monitoring, there are a lot of assets where oil samples or vibration or temperature are perhaps better than sound. So traditionally, I think vibration is perhaps a better method for condition monitoring inside the nacelle than sound. We can certainly do it, but I think there are probably better other technologies which can be used in that scenario.
Matthew, the amount of processor you have on board, it's really impressive. And as you try or install the system in different places around the world, obviously there's a little bit of tweaking that'll have to happen over time. Is the board updatable? Can you update the board and make it more powerful, kind of like you do with your iPhone? It just updates overnight and boom, you got the next version? Yeah,
you've exactly got it. So through using the cellular technology, it's a two-way communication path, isn't it? So we send up small packets of data, but we can update our firmware. So our firmware is where all the analysis is done. So we can definitely update our software. So just one little story. We had a pilot going on, and we weren't able to update our software remotely. So I basically had to fly from Australia to West Virginia just to update software on a number of devices. So that was not an easy task, and I don't want to be flying for 20 hours to just update software.
Those are the hard lessons you learn, right? I mean, that's how the engineering world works. You get stuck in an airplane for a full day. You think, I'm never doing that again, and then you make the hardware work. But in that particular case, I think it's very fascinating because there's so many different parts of the world. Like, and as we start growing into offshore wind, the environment out there, I'm thinking off the coast of Scotland or the coast of Massachusetts where I live, or even off the coast of Australia. There's just different noise signature, wind profiles, animals, sea life, boats, whatever.
Yeah.
How do you have to sort of fine tailor that as you get in different parts of the world eventually, just because they're just so different?
Yeah. So actually, we coincidentally we're having our first offshore wind farm deployment off Scotland. Right at actually maybe tonight my time.
Tomorrow for
you,
us?
whatever the time zones are. In the future for both of us, we've got some of our devices going to an offshore wind farm to basically test. We've made some changes to our system to anticipate what it's going to be like offshore, but it's going to be a learning experience for us. I guess the good news is that we've worked out ways of excluding the sound we don't want to listen for onshore, and things like the birds. But there are birds onshore. There's birds offshore. I think it's probably the waves. The waves and wave sound is the thing that we're not familiar with. Someone told me, so we've got to validate this, but the typical wave frequency, like a wave will come past every 8 seconds or so. So 8 seconds or so, there'll be another wave comes through. However, the blade is rotating roughly every 1 to 2 seconds or whatever it turns out to be. So we can still separate the sound from the blades from the waves. So we're quite hopeful that our system will work without much modification.
Well, what were some of the other challenges that you had to implement to get yours ready for offshore? Because obviously, I'm sure you can't put it in the same 4 meter off the ground location, right? Because obviously, the turbines have that big base and they're projected out of the water a certain amount, but you've still got to make sure you're out of salt spray and a lot of those different hazards. I mean, what are some of the other considerations getting it ready for the ocean?
Yeah, probably the corrosive environment. The sea air rusts everything. Well, if it can be rusted. So trying to minimize the steel content, use stainless steel instead. So that we've made some changes there. Sort of the coating the metal. So we've painted the metal rather than just using straight chrome. So offshore we can't use this chrome. Yeah, it'll rust in a day. And then also coating some of our electronics. So some parts on here are quite susceptible to corrosion. So we've applied some additional coating to that. So there's some of the things that we've done down to address this corrosive environment.
When you go offshore like that and you have sensors monitoring a number of offshore turbines, you still have the insect and bird issues where critters like to make homes and devices like yours or put a nest on it. What is the design incorporated to prevent that from happening? Yeah,
we've been very careful about that. So once again, a few stories here. On another site, we went back there and ladybirds had found their way into our windshield. So we had some holes. They found their way in. Okay, so ladybirds found their way in. And then what happened? Some flies found their way in as well somehow. And then finally, spiders found their way in. So once again, we learned the hard way. We had a whole little ecosystem going, but they couldn't get out. So it was quite ridiculous. But yeah, it was sort of spiders following their prey. So once again, lesson learned, no holes, make sure everything's sealed up. So we really worked hard to address those sort of environmental challenges. So it's funny how we're doing acoustics, but some of our biggest problems have been not the acoustics; they've been other things.
Spiders. Spiders are everyone's problem. Yeah.
Goats, cattle, some people. So there's a whole lot of other problems.
Well, I imagine, if your anti-theft system is just like, is it the Naval Academy, Alan, here in the U.S. that does that, where they grease the statue and everyone has to try to get to the top of it? It's like,
yes.
I just imagine you guys greasing the bottom of the turbine so no one can scramble up to steal your device.
In Germany, the wind turbines tend to be like one turbine. That's it. It's not a farm. It's a single turbine. And I've seen pictures of one of our installations in Germany, and the whole base of the tower has got graffiti everywhere. So obviously very accessible. What we've done, once again, our device is high enough that they can't climb up the tower.
Well, those are the things you learn through hard knocks, and I know you've been working on this project for several years. How from sort of start to today, how many years of effort have been into this product?
It's actually around 8 years. So the first challenge was 8 years ago. We had to do research into was it a real problem? Was it worth solving? Was it something we could actually listen for and pick up? And then the other thing that sort of we had to work through was just, I think, Alan, you've already mentioned it a couple of times, just the processing power and to get the batteries right. So 8 years ago, these things were consuming a whole lot more power than they are now, and it wasn't really feasible. The technology's caught up to where we needed it to be, and so it's been a 8-year journey.
Well, as an operator of wind farms, that's probably the most important salient fact of the discussions a lot of times, particularly like on a product like ours, is lightning protection, is, well, how long has it been in service and who's tried it and have you proved it out? Well, for us, we've been out there about 10 years and we've been on hundreds of turbines and we're having great results. You're kind of at that stage right now where you've got a couple hundred units out in service, and that next stage is, it's no longer validation, it's implementation. And that's a big transition, or can be a big transition for a company in terms of just starting to mass produce, support. Are you going through that transition now? What is that like as you start to expand your reach around the world? What is that like as a company to do that?
What's the term? Growing pains. So it's a transitioning from maybe 20 or 50 up to the hundreds. It's quite a transition. We have a variety of supply channels, so we can scale up our supply. So that's all pretty straightforward. It's the probably the people aspect. So people were used to doing a whole lot more R&D, a bit rough and ready, and they've got to now transition. So our team has to transition to provide more, a high quality commercial product rather than something just sort of thrown together. So it's probably our team adjusting and the increased testing that we have needed to do, and the change of organization within our team to shift. That's probably been the hardest thing, actually. I can order 10,000 of these tomorrow. So,
right. But that does make a difference, though. I think you're right. From the engineering staff and all that, the mindset has to really refocus that you can't just willy-nilly make changes to something you've proved out. You need to take that to the side. Product to customers is product to customers, and it needs to be consistent, and we need to know what it is and how it's going to work no matter where it's installed, right? And so the engineers, you kind of have to rap on the head a little bit and say down, just make consistency. And from a wind turbine owner operator side, that's exactly what you want to see, right? You want to see just consistency. You want to take this unit out of the box, put it on the turbine, bam, every time it's just like clockwork, I know this thing's going to work. And that's a totally different structure, but it's also a financially aggressive structure in terms of just eating up resources. Your company has obviously grown over time. How are you handling that expansive growth? You have investors, obviously. How is that going from the business standpoint and supporting all this great technology? What does that look like?
So we have grown. We do have external investors, like you say, Alan. But we've also, received a lot of, mentoring and support to help us on the journey. So it's been a mixture of training, mentoring, finance. Yeah. It has taken more resources. Sure. The whole learning process, do things better, quality control, learning from mistakes, and the team working together. So I guess it's like making a perfect cake. It's not easy.
It's not easy.
And with more experience, it gets easier. With the right ingredients, it gets easier.
Well, where do you see this going a year from now? Just watching from the outside, it looks like to me, I can't imagine any new project going on or even existing projects where this technology shouldn't be at least evaluated or just installed, for goodness sakes. What does that next year look like for you? I mean, where do you see this thing going in the relatively near future?
Right today we're in the hundreds. We want to be in the thousands. So
sure.
In 12 months' time. And we're gearing up to that. We have found that where we provide the best value is the newer turbines with longer blades, with higher risk, and sure. Some of them might have lightning risk as well. So,
sure, they do.
They do.
Yeah.
So that's probably where we're focusing. I think. Our numbers are suggesting there's something like 500,000 wind turbines around the world today. And that's sort of expected to double in the next 10 years. So, I think we've got a great opportunity to help. It's basically helping lowering the operations and maintenance costs, which is great
sure.
for everyone.
Well, and what does that ecosystem look like? So obviously, if I'm a maintenance company, I'd love to be connected with you because you're going to tell people as soon as they have an issue, right? And I can go out and fix it. So, I mean, what are the partnerships and what does that whole ecosystem look like? Because you guys you're the messenger, right? And you fit into that whole maintenance cycle. But what does that look like for you guys in the future?
Good question. So initially we were just working directly with operators. So various operators that are doing self-performing blade repairs. So we've been working with them directly, and that's been a really neat fit. But like you say, we're part of the puzzle, but we're not the whole puzzle. So we're starting to build up partnerships with a number of other key well-known operators in the space. So the logical partnerships for us are visual inspection companies that we talked about before, because it's complementary, and there are some very forward-thinking visual inspection companies that see this as complementary to what they're doing. There are also some monitoring companies, like we talked about, drivetrain monitoring. Monitoring for condition. So there's some partners that we're looking at in that space where it's complementary to what they're doing. So we're trying to find some arrangements where the combined companies provide a much better solution for the end customer. Mm-hmm. So that's sort of the approach. We're obviously also talking to the OEMs with. Our ultimate aim is obviously, as we said, to get our device installed on each wind turbine as it's installed in the first place, rather than aftermarket. So we're working this from multiple angles, as you'd probably expect.
Yeah, I mean, I think that makes perfect sense where, at the end of the day, everyone's systems can sort of tie together where they get an alert and, the drone inspection company can ping the wind farm operator or owner and say, hey, we got an alert from ping. Do you want us to go out and take a look? Or maybe they don't even need to ask for authorization. They just have authorization where when we get an alert, we're going to send someone out. Then we'll let you know once we've taken the probability and gotten eyes on it. And hey, here, you don't even have to worry about this. We got a notification. We checked it out. There is damage. What do you want us to do about it? That seems like that makes sense as a workflow.
Dan, that next generation of wind turbine monitoring is obviously the ping device sending out a signal to your favorite, a drone that's located on the wind turbine that just plops up and starts taking pictures. That's where we're headed. There's no stopping that right now. That is the future because we have the computational ability to handle it and the processing speed and the battery power and all those little things you don't think about are all in place today. It's, your Condor monitoring the wind turbine concept is kind of getting fruition where you got this listening device and then an imaging device coupled together. That's the future. I mean, I think, Ping's obviously set up in the middle of this as in a really sweet spot is you spend so much time developing the proper technology for the right time to connect to the rest of the ecostructure that exists on a wind turbine. And those relationships are going to be really interesting to watch because one can only imagine as to what the opportunities are. But those opportunities have got to be worldwide. I mean, you're in Australia. A lot of obviously all wind turbines happen in Denmark and Germany. How do you manage all those world connections? It seems like you're in different time zones anytime you're making a phone call.
Yeah. I think, like I said before, we're nearly up to 10 countries where we've deployed. So our main interest has been North America, a lot of interest through Europe, but also back through Turkey, India, Asia as well. So to be honest, my day starts with talking to North America and it ends with talking with Europe and India and Turkey sort of fit in between. But I mean, from our point of view, it's the same technology all over the world. Our business model is to send the devices to our customers so they install. So whether it's in Germany or France or in Canada, it's from our point of view, it's the same thing. So we're just sort of building up our infrastructure so we can deal with the different customers around the world. But it's still the same device, still the same listening. So that's how we've built up our business model.
So when did you know that this is going to be a worldwide thing? How many years ago do you realize someone in Australia who worked on wind farms said, we can hear wind turbine blades with problems. You're 3 years into this and then all of a sudden you're getting a phone call from Turkey. At what point do you realize wow, this is a global thing. This is not a local thing.
I think it probably started with my first wind turbine blade conference I attended. That was in Denmark. And from that very first conference I attended, the people I met, it became apparent to me very quickly it's completely global. So that's when I knew people just got it and it's global. So that was sort of the first inkling. And then a few years later, we, once we got the few things sorted out, was it a problem, blah, blah, blah. Then I started making a bit more contact with some of the OEMs and some of the operators. And to be honest, they were really, really receptive. So that's sort of, I think, when the penny dropped. Okay, we've got something, we've shown that it works, we've got people that actually, are excited about it. And I think that was the point in time. That was roughly around 3 years ago where we thought, we've really got to put the foot on it. Put the foot on the gas pedal.
Yeah.
So I want to jump back to the automation piece. So obviously a lot of the jobs that end up getting replaced by automation are like the endpoint. So, where you have a computer system and you have a human working the desk to check someone into the system, right? You walk in the door to your, whether it's a gym or an office, and you say, "Hi, I'm here," and the human checks them in. Obviously, that's a job. It's like, well, let's just let him touch the screen himself and replace that job, right? Which kind of feels like what I was just kind of alluding to, which is, your ping system says, "Hey, we've detected something. There's a high probability that there's X kind of damage." I mean, is that where you see this kind of going in the future? Is where that gap just doesn't have to go to a person. It just gets closed, where it's going to go right to the drone company, or it's going to go right to a drone or a robot, and then it's just going to. How do you see that sort of automation ecosystem play out?
Yeah, I think it's a tricky one. I mean, my dealings with the blade engineers across the OEMs and operators is that at the moment it still requires a lot of human expertise as to, what is the damage, what does it look like, how am I going to prioritize. I've got the ping results, I've got the drone results, but I'm still going to prioritize and optimize around that. So that assessment piece is still, I think, super critical. I mean, in some ways, what we want to do is have repairs being done faster. So, I mean, ultimately, our aim is to have repairs made when it's smaller. So we're trying to save time on repairs, but so I think that's probably the end flow on. We want people to be having less time up tower. So that's probably the end point.
Yeah, that makes sense. Because you're right. I mean, those higher level decisions, and this was something Danny Ellis from SkySpecs talked to us about, last year when he was on the podcast, was that they try to help operators understand, hey, this type of damage is this level of severity, so therefore you maybe want to prioritize this now or put it off. This one's safe to put off for a couple years. Maybe let things aggregate and then go up there and do it all at once, that kind of stuff. So yeah, I think that hearing from lots of different people in the industry, it's not just, oh, there's a problem, let's go up and fix it right now. But it's like you said, that complex decision of, can we lump these together? Maybe how can we save money? What's really a priority today? What's not? What's the environment like? Because if it's a really harsh, Australian summer, or if it's a really brutally cold place, maybe that needs to be fixed sooner, because it might, become exacerbated by the cold or by the extreme heat, something like that.
One thing, I think probably one of the key game changers for us is that because we're doing daily reporting, we can actually track the progress of damage. How fast is it actually getting worse? So depending on the rate of damage, if it's only just getting a little bit worse, maybe you can let it go for longer. So, these operators haven't had this information until now. So, some sites we've seen the damage, it goes up quite quickly. On other sites, on another one, we've seen that the damage got worse, and then it flattened off. It didn't keep getting worse. So there's a whole lot of work that can be done around optimizing based on the rate of change of damage as well. So knowing when it's occurred and how it's propagating is also very useful. And that's probably where the big data piece comes into it later on for us.
Oh yeah, it does. It's going to be a huge. There is going to be a huge infrastructure analyzing that data, not just for the obvious things, but they're going to start mining that data to figure out other things you wouldn't even consider. And that's where you're going to see this industry be created from a sensor as like yours, which is really complicated, but that data is such a valuable piece. And there's so many good analysts in wind turbine industry right now that can mine that data for all kinds of unique features. And it's not just a device. You are really creating an industry behind you, or internally even, that the door's barely cracked on that industry yet. And that's the fascinating and exciting thing about all of this, is that we've gone from that simple technician looking at a blade or listening to a blade to something that makes a lot more sense in terms of where we're going to stick wind turbines. And we're just beginning it now. And as you get more offshore, you're going to be pulling more data. What offshore looks like, you're going to be pulling off data. What West Virginia looks like, and those will be two different things. And we're going to find out more interesting things. But is that part of that growth of ping? Is the sort of the data analysis part and the looking at those fine nuances that may not mean that much today, but could mean millions of dollars for an owner a year from now?
Yeah, I think someone, one of the operators told me that data triangulation is super critical. So taking a sensor and then comparing it to the results from another sensor, and then tying that to another bit of data. So I think that data triangulation is where the most value will come. So I see us as being part of the ecosystem, as part of where data points that feed into the data pool. So I see us working with partners to get the most out of that data. So I think it's important to know where our boundaries are and should be. And then work with other people that can take it further. And there are some startups around the world which are doing more and more work in this space, trying to get more meaning from all the data that's coming from wind turbines.
So one of my final questions for you is really just, what does a walkthrough of getting this up and running look like? So I know it's a subscription fee, but if I was say, hey, all right, like the deal's signed, like what do I expect next as someone who's signed up for the ping system?
Yeah, so our processes are getting more of a sort of logical flow to them. But what the flow is looking like is we provide training videos on how to install, how to set up, and some useful information for the site. So we try and send that. So if we get an order, we ship the devices, and at the same time we do a few other things. So we ship the devices, and while they were in transit, we provide some training material. We also set up our cloud infrastructure. So when they're turned on in the field, they show up. We set up the users, so different users have access to the cloud. So we get them sort of set up, and then when the ping monitors arrive on site, we provide training. So the technicians who are installing it, we work through how you install it, how you plug it together, what you do. There's some lights on the back. What do the lights mean? And then the technicians install, and then we start getting the data flow. Then we start to get the results come through, and that's where we go into that sort of initial sort of scaling, benchmarking phase. So we work with the operator and just talk through, okay, this is what we're getting. And we match that against the latest visual inspections. So we sort of do a bit of a correlation with known conditions against what our system is saying. Get the scaling right. Then the next thing is fine tuning the alarms that our system sends. So we've got different settings. So some people just want to see if there's a very small change. Other people just want to only see the outliers. So we work through this alarm setting process. And then what we love to do is just keep in contact. So with a good number of our customers, we're having fortnightly phone calls just to check in, see how it's going, and keep an eye on things. And then we also get some feedback as to how it's going for our customers, so we can improve the way we're showing data. Or so one customer in particular said that they'd love to see like a message board. So rather than just emails, they want to see like a message board which sort of summarizes, these are the last alerts, this is the notes, this has been actioned, it's been acknowledged. So we're getting some great ideas from our customers now that they're using our system.
So kind of like a Slack feed, maybe something like that, where they can kind of go back through it rather than having to rummage through emails. That makes sense. That's like the nice feature about Slack, is that yeah, if you can go back through everyone else's conversations on it and, run back through a month's worth of messages pretty easy rather than trying to find them in your nightmare of an inbox.
Yeah,
So
yeah.
yeah, that's interesting.
Yeah, there's a term of alarm fatigue. So if people just continue getting alarms, they
cry
just,
wolf.
Switch off. Yeah, they switch off, and then exactly.
Well, Matt, this was a great conversation. I mean, it's such interesting technology, and like you said, it's something that's going to continue to evolve as you learn more and more, getting further and further out there. But we'll hope to see you on some of the big U.S. Projects coming up, because Lord knows we're moving fast, putting big offshore wind farms in. So hopefully we'll see Ping services out there. Where can people follow up with you and learn more about it and see it in action and all that stuff?
Yeah, pingmonitor.co is our website, so that's probably the best spot to go. Also LinkedIn, Twitter, but probably the website's probably the easiest spot to go. I'm super happy to jump on calls with people just to explain what we're doing and answer questions. And love to work with new operators, new partners all over the world. And perhaps I should have said, actually, around 80% of our systems are in North America. So North America has been a fantastic early adopter of our technology. So thanks to you and all your listeners.
So more 20-hour flights are in your future, is what you're saying.
Yeah, maybe not for a little couple of months, but maybe 12 months into the future. Well, hopefully, right? I mean, I'm sure you'll sacrifice a little bit of sleep to get on some of these huge projects that are in the works here. But yeah, well, thanks so much for coming on the show. We really appreciate it. Well, thank you, Dan. Thanks, Alan. Really been great to talk to you and share a little bit more about what we're doing. All right. Well, that's going to do it for our episode of the Uptime Wind Energy Podcast. Big thanks again to our guest, Matthew Stead, CEO of Ping Services. Be sure to check out the description, whether you're on iTunes, YouTube, Spotify, wherever, where you'll find links to their company, their YouTube channel, LinkedIn, all that stuff, so you can follow up with them. And be sure to subscribe to the show, share it with a friend, and we will see you here next time on the Uptime Wind Energy Podcast. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.